Group 3, their name is called the Symphony. And the title of the presentation is Simple Symbols, Fewer Sirens.
Honorable judges, ladies and gentlemen, good afternoon. In 2025, an enormous barrier lake burst in Hualien, causing severe damage with an estimated discharge volume of 60 million cubic meters. Grieving over this incident, we came up with a solution with the help of self-priming siphons, which can operate without pre-filling the tubes. Could we utilize this unique siphon to drain the liquid from barrier lakes and prevent them from collapsing? Aiming to create a sustainable drainage solution, we initiated our experiments. First, we tested the correlation between tube diameters and salt concentration, which served as a condition where dissolved substances do not precipitate. Second, we tested the correlation between tube diameters and cornstarch concentration, simulating the viscous and precipitating fluids in barrier lakes. Our goals were to identify the tube with the highest efficiency, observe its performance in different solutions, and then record the results. Jason, the stage is yours.
Thanks, Ryan. The results of our experiment revealed two major findings. First, in both salt and cornstarch solution, the 6 mm self-priming siphon, represented by the blue bars in the charts on the very top of the page, has the best drainage ability. Not only does the 6 mm siphon has the highest drainage speed, but it also has a higher concentration tolerance, with the highest value observed at 20%. This observation can be further supported by the trend lines down here. Second, before reaching the highest concentration, which is the siphon's maximum concentration limit, the drainage speed in cornstarch solution has a much smoother trend line than that in salt solution. This suggests that under conditions closer to real-world barrier lake scenarios, the siphon can work more stably and more consistently. Timothy, can you tell us more about it?
Of course, Jason. We compared the experimental results with the actual conditions of Hualien Barrier Lake. The draining speed of the 6 mm siphon operated in a 23% cornstarch solution is 4.022 cubic centimeters per second. In order to drain the volume of 60 million cubic meters from Hualien Barrier Lake within 90 days, it is approximately to utilize 1.9 million siphons. As long as we reduce discarded plastic straws, we could achieve a win-win situation between plastic reduction and disaster relief. In conclusion, our study provides reference for future application. Not only can natural disaster be mitigated, but the siphons can be utilized in hydraulic engineering. Aligned with SDG 11, Sustainable Cities and Communities, and SDG 12, Responsible Consumption and Production, we can prevent adversity from happening again. Simple siphons, fewer sirens. Thank you.
Thank you for the interesting presentation. So you get your inspiration from the Hualien Barrier Lake?
Yes.
And did you really believe that you can use straw to drain the water out? Because from your experiment, you need to add sodium, right, into the whole mechanism, right? That's the kind of service mechanism, one of the driving mechanism. So how do you think you can implement that?
Thank you for asking. In our experiment, actually these two experiments are conducted separately. So when we do the cornstarch solution, there is actually no salt in it. And we choose cornstarch solution because on the upper layer in barrier lake liquid, there are going to be like sand or dirt. There are tiny particles in the liquid. So that's why we choose cornstarch solution, and we don't have to put salt into the cornstarch solution before we do it. So that's our answer.
I didn't really get the point. Like the cornstarch means the you simulate as the water inside the barrier lake, right?
Yes.
So do you need to fill the water into the straw first?
No, because the mechanism behind the self-priming siphons is that due to its Due to its special shape, that different height differences and the water pressure, it can make it to automatically operate in the water. So we don't really need to just operate it again and again, and it can just do it by itself. Thank you.
Once we dip it into the water, it could just operate by itself. We don't need to pre-fill the liquid into the tube. So that's why we choose it.
Okay, thank you.
Thank you.
Thanks.